In this video, we are going to go over a few numerical reasoning problems. These problems can be tricky for a lot of people. There's no formula to do them. They just kind of take critical thinking and numerical reasoning. So before we start, if you want to pause as I flip through each of these problems, you can give them a shot on your own. And then once you do that, you can continue the video and you can view my explanations. The problems are ordered in order of ascending difficulty, so we're starting with the easiest and ending at the hardest, so don't be discouraged if you feel like you're getting less right as you go. These problems can be tricky, but like all problems on the SAT, practice makes perfect. The more practice, the better, the more confident you'll be. And when you go in on test day, you won't be worried that you only have 20 minutes, because you'll be confident that you can work out the answer before time runs out. Okay, that is all the problems. Now, starting at the first one, let's go over the solutions. Okay. So if n is 3 times an even number, which of the following could be n? So 3 times an even number. That means our answer for n has to be divisible by 3. So right away, 14's gone, 16's gone, and 17's gone. That leaves us with 15 and 18. Both numbers are divisible by 3, but one is divisible by 3 and the factors are 3 and 5, and the other one divisible by 3, the factors are 3 and 6. So since 18 has the even factor, then the answer is 18. That's an easy one, but they ramp up here as I'm saying. As I said, sorry. Next. If n is an integer, which of the following must be an even integer? So for this one, well, let's just take a look. The only requirement on n is that it's an integer, which means it's a whole number. No decimal, no fraction. So for a, n over 2. Well, if n is an odd number, n over 2 is actually going to be a decimal. It's going to be a 0.5, so a doesn't work. B, n plus 2. Well, adding 2 to a number just preserves if it's even or odd or not. So once again, if we start with an odd integer n, n plus 2 is still going to be an odd integer, so B does not work. C, 2n plus 1. Now, multiplying any integer, even or odd, by 2, the result is going to be even, and then adding 1 is going to make it odd, so C does not work either, because C will always be odd. D, n squared. Well, if we start with an even integer, then n squared will be even. Say 2 times 2 equals 4. But if we start with an odd integer, say 3, 3 squared, 3 times 3 is going to equal 9, which is odd, so that doesn't work. Finally, we get to E. N squared plus n. So let's try it. For an even integer, 2 times 2 plus 2, that equals 6. And for an odd integer, 3 times 3 plus 3, that equals 12. So this works, because an odd integer squared is another odd integer, but then we're adding an odd number to that odd, and an odd plus an odd is always even. So we find that E is our answer. Moving on. If a, b, and c are positive even integers such that a is less than b, which is less than c, and a plus b plus c equals 60, then the greatest possible value of c is. Okay, so since we're trying to maximize c, and we have this condition that a plus b plus c equals 60, then we know we want to minimize a and b. Furthermore, the condition that a is less than b, which is less than c, shows us that these all have to be different integers. They cannot be the same. So let's have the lowest possible values of a and b. We'll say a equals 2, which is the first positive even integer, and then b equals 4, which is the next positive even integer. And then we rewrite our equation a plus b plus c equals 60 as 2 plus 4 plus c equals 60. We simplify it further and we say 6 plus c equals 60, and then c equals 54. So the greatest possible value of c is 54, and the answer is D. That one wasn't so bad, right? All right, moving on. If b is a positive integer less than 100, then how many integer pairs satisfy the equation a over b equals 1 over 10? So don't get thrown off by the notation, the coordinate pair type notation. All this is saying is how many pairs of a and b are there to satisfy this equation when b has to be less than 100. So a positive integer less than 100. So let's start off. We know if a equals 1 and b equals 10, that works. That's 1 over 10. We can continue, say a equals 2 and b equals 20. That works because that simplifies to 1 over 10. And we just kind of continue up the ladder here. 4 over 40, 5 over 50, 6 over 60, 7 over 70, 8 over 80, getting redundant, I know, 9 over 90, and then we stop, because the next one, if you can follow the pattern, would be 10 over 100, but this doesn't work, because this would mean a equals 10 and b equals 100. That means b is not less than 100. That doesn't work, so we count out the ones we do have, 1, 2, 3, 4, 5, 6, 7, 8, 9, and the answer is C. There are 9 integer pairs that satisfy the equation. Next, the first day of a particular month is a Tuesday. What day of the week will it be on the 31st of the month? So for this, we're going to start with the fact that the first is a Tuesday, and we're gonna continue counting up each week, seeing when the next Tuesday will be. So the next Tuesday will be the 8th, 7 days in a week, right? The next Tuesday after that will be the 15th, 8 plus 7. The next after that will be the 22nd. The next after that will be the 29th. And here, we're so close to the 31st, we want 2 more days. We say the 30th will be a Wednesday. And finally, the 31st will be a Thursday. So that's our answer. B, right there. So sometimes these problems can sound tricky at first, but none of them take more than a minute to solve if you know what you're doing. So practice, practice, practice. Okay, the population of Boomtown, that's a funny name, doubles every 18 months. In January 2000, the population is 12,000. When will the population reach 96,000? Okay, so for this one, we're going to make a little table. We'll start off where the population is 12,000. Now the population doubles, becomes 24,000. It's going to double again. It's going to become 48,000. And it's going to double one more time. 96,000. All right. Now it's 12,000 in January of 2000. And now the next time it doubles is 18 months. So let's add 18 months to January 2000. First we'll add a year, which is 12 months, and it'll become January 2001. And then we're going to add 6 months. It'll stay in 2001, but it'll become July 2001. You can look on a calendar if you don't believe me. And now we'll add another 18 months. First we'll add the 12, which will bring us to July 2002, and then we'll add the 6 months, the half year, and that will actually bring us to January 2003. All right, one more time. We add 12 months, that brings us to January 2004, and then we add 6 months, which brings us to July 2004. And let's see if that is one of our answers. It is indeed. E, July 2004 is the correct answer. Okay. This one says, if x is greater than x squared, which of the following must be true? So some of you will recognize right away that the only time x is greater than x squared is if x is less than 1. And just to show you what I mean by that, if x equals 3, then x squared equals 9, and x is not greater than x squared. But if x equals 1/2, then x squared equals 1/4, and x is indeed greater than x squared. So right away, we know condition 1 is true, because x has to be less than 1 for this to be true. Let's check out condition 2. X is greater than 0. Well, so this is saying x has to be positive. What if x is negative? Let's check. If x is negative 1/2, then x squared equals 1/4, and x is not greater than x squared, because two negatives multiplied together equal a positive, and a negative number is always less than a positive number. So 2 must also be true, because we need x to be positive. So we write true here. Let's check out 3. X squared is greater than 1. Okay, well, in this case right here, x is indeed greater than x squared, and x squared is less than 1. So that proves number 3 false, because we have an example that proves it false. And then the answer is 1 and 2 only, C. Right there. Moving on. If a, b, and c are consecutive positive integers such that a is less than b, which is less than c, and ABC is not a multiple of 4, then which of the following must be true? So ABC is not a multiple of 4, and A, B, and C are consecutive positive integers, like 1, 2, 3, or 2, 3, 4, or 5, 6, 7, or 11, 12, 13, etc. So the thing that they want you to recognize here is the fact that any two even numbers multiplied together become a multiple of 4. And that's because in any even number, any two even numbers, we'll say x and y, they have to be divisible by 2. And this is arbitrary. It depends on what x is, depends on what y is. But 2 is a factor. So if you multiply x and y together, one of the factors is going to be 4, no matter what, because the 2 and the 2. So realizing that, you might say, well, then b must be even, because c would be odd then and a would be odd, because they're consecutive, and numbers go odd, even, odd, even, odd, even. But not everyone's going to realize that right away. So another thing you can do is just try different examples. That's always an option with questions like these. So let's start at the beginning. Let's say a is 1, b is 2, c is 3, and that equals 6. Let's keep going. Let's say 2, 3, 4, and we get 24. Let's keep going. 3, 4, 5. That equals 60. Continuing, say 4, 5, 6 equals 120. Let's go one more. 5, 6, 7 equals 210. So out of these numbers, you can check on your calculator. The only ones not divisible by 4 are this one and this one. And what do these two numbers have in common? The middle number, which is b, is even. And that's another way to find the answer, by substituting in. So the final answer is b. B is even. Okay, this is a fun one. 6 buses must carry 200 students. If each bus must carry no more than 40 students and no less than 30, what is the greatest number of buses that can carry 40 students? So the question's pretty self-explanatory. Let's just start. Let's see what happens if 6 buses are carrying 40 students. 6 times 40, that adds up to 240 students, which is more students than we have. We only have 200, so that is not going to work. Let's try 5. 5 times 40 equals 200 students. That's within our students, but then there is 0 students left to split among one bus, which means there will be 0 students in one of the buses, and that does not work because every bus has to have at least 30 students. So let's try 4. 4 times 40 equals 160, which leaves 40 students to be divided between 2 buses, which equals 20 students in a bus, which is less than 30, so that does not work. Let's try 3. 3 times 40 equals 120, which then leaves 80 students to be divided among 3 buses, and this is still less than 30 students per bus, so it's not going to work. Let's try 2, the last possible answer. 2 times 40 equals 80, leaving 120 students to be divided among 4 buses, which means there will be 30 students in each of these buses. That works. So our answer is E, 2. All right. this one. If r and s are positive integers and s plus 1 equals 2r, which of the following must be true? 1, s is odd, 2r is even, 3, s over r plus 1 over r is an integer. Okay, so let's start by writing out s plus 1 equals 2r. And right away we notice something about each side. About the right side, it will always be even, because any integer multiplied by 2 is going to be even. Let's check out this side. S plus 1. So it's always going to, even or odd, it's going to be the opposite of what s is, because adding 1 changes between even and odd. So if s is odd, it'll be even. If s is even, it'll be odd. So since this one is always even, and this is going to change, this is going to be the opposite of s, even or odd. So we need s to be odd. Therefore, plus 1, it'll be even. So we see 1 is true right off the bat. True. 2, r is even. Well, this equation can still hold if r is odd, because if r is an odd number, the side will still be even, and then s plus 1 can still easily be made even with s being odd. So 2 is false. 2 does not need to happen. 3, just to reiterate, s over r plus 1 over r is an integer. That means it's a whole number, no fraction. Well, here we go. Well, let's manipulate this equation a little bit. S plus 1, let's divide both sides by r. Then we get s plus 1 over r equals 2. We split that up into s over r plus 1 over r equals 2. And that's exactly what the third condition is. And it equals an integer. In fact, it'll equal 2. So 3 is true. So our answer then, finally, is 1 and 3, which we see is answer D. All right. Last question, the supposedly hardest one, but I'll show you how to do it, and you'll go, oh, that's not that hard. In this addition problem, in the corner right here, in this addition problem, each letter represents a non-zero digit. What is 2r plus t? So you need to recall how this form of addition is carried out. I know you probably haven't done it in forever. But what happens is you add by column starting at the right, and if the number is more than 10, you just write the ones digit, you carry the tens digit over here, and then you add it to that column. So for example, if you have 15 over, let's see, then 51 plus, it would be 6, 5 plus 1, 1 plus 5. So already we see, because of this example, and the answer is 3 digits, that s plus r is going to have to be greater than 10. And in fact, s plus r is going to have a 4 in the ones digit. So we can see right here that s plus r equals 14. Then we would carry the 1 over, put it up there, and then 1 plus r plus s would have to equal r. Or the ones digit would have to equal r. But we see this is the same addition. You can switch the order, and it's going to be 1 more. So it's going to be 15. And then we carry the 1 over, and then there's nothing left here. So we see t is going to be 1, and r is going to be 5. Now let me just go over that again in case you missed it. So s plus r, 4 is going to be in the ones digit. We carry the 1 over. 1 plus r plus s, which is going to be 1 more than s plus r, because the order doesn't matter in addition, is going to be 15, because we already know this is 14. And we know that r is the ones digit of that answer, so we know r is 5. And then we carry the 1 over, and there's nothing left to add it to, so t is going to be 1. Finally, we say 2r plus t is the same as 2 times 5 plus 1. And you could do that pretty easily, and it equals 11. The final answer is D. So that was just a few numerical reasoning problems. A lot of people have trouble with them, but you just need to practice them. And yeah, that's really the only way to do it. So thanks for listening. Keep studying, keep practicing. Anyone can do this stuff. Just practice makes perfect.